What's up, guys? Here we go, section 5 of chapter 1. And in section 5 of chapter 1, we're going to talk about three main things. But you see on the screen here, it's going to be this epic battle of the versus bisect and trisect. Just kidding. All we're going to talk about really is this: bisect, what it means, how to identify it, how it's used in two-column proofs, and trisect, same thing. But I'll tell you, from the word bisect, there's another word called midpoint. Now, midpoint, bisect, trisect. Those three things, I promise you, you're going to see the entire year, even up. I mean, there's questions on the midterm about it. But here's the thing. Concept-wise, they're very self-explanatory. Midpoint, bisect, trisect. Very self-explanatory. What you need to focus on in this video is not so much, yeah, I got bisect. It's the exact wording that you're going to see in the video of what bisect is and how it's worded, because it can be flipped around, and you need to be very specific with how it's worded, and you need to memorize it, because you're going to see these things are what's used in two-column proofs to be able to prove many things throughout the year. So it's not so much the concept. You'll get that for sure. It's a piece of cake. I'll even show you a quick example in real life of how to know what bisect and trisect is. It's simple. But you need to write down everything that's on here in the examples, but especially the wording of the definitions of bisect. Okay? So let's do this. Let me show you a quick real life example. What you see is, here's me, back in my high school days of doing a talent show. Just kidding, I have no idea who that is. But what you see here on the screen is one wheel. That's called a unicycle. If I have a two-wheeled thing like that, that's called, a bicycle. And if I have a three-wheeled thing like this, like my little study 3-year-old's, weird 3, it's ironic. But anyways, he is going to be 3 in October here coming up. Anyways, so that's a tricycle. So here's the scoop. Remember this. This prefix bicycle right there, bi, that prefix bi, it means two. Like if you look at this enormous bicep that you see right here in front of you on the screen, that bicep is actually made up of two main muscles. Tricycle means 3. There's 3 wheels on there. It's 3. Your tricep, by the way, back here, that tricep, it's made up of 3 muscles. Oh, by the way, your quadriceps are made up of 4 muscles. Yeah, you're welcome. Little extra love there for some knowledge. Anyways, so bicycle, bisect means 2. Tricycle, trisect means 3. Why'd you put unicycle in here? It means nothing to geometry, guys. Nothing. But it was a cool picture. Okay, so let's go to, first of all, what we're going to talk about is segments. And what it means for segments to be bisected and trisected. In fact, let me do this. I'm going to cut over here. Whoops, wrong one. I'll cut over to this picture so you can see it. So what you see is I have a simple little segment right there that's 20. This one here is 21. We'll get to that in a little bit. But over here where it says AB, that is 20, if I take that particular segment, guys, and I divide it directly in half, like say for example there's a point right here and we're going to call it point M. That point right there directly in half, where this segment is congruent to this segment, which would make this 10 inches and this 10 inches. Of course, you can do the math by just dividing that by 2. But if I divide the overall segment into 2 equal parts, so now I have AM, that segment, being congruent to segment MB. If that's the case, well then this segment has just been bisected. It's been divided into 2 equal parts. Likewise over here, if I have a point here, we'll call it X, doesn't matter. And I put a point here, call it point Y, where this is congruent to this, is congruent to this. So you take the overall 21 inches and make this 7, make this 7, and make this 7. That segment is said to be trisected. It's trisected. And this over here is bisected. So that's bisect and that's trisect. Very simple. But I do have to show you this one very, very important thing, and it's this. This point right here, that point in which is doing the bisecting, it has a special name, and it's called this. It's called, yes, you should write this down. It's called the midpoint. And again, it's that point right there. It's the point that's doing the actual bisecting. Now these points over here, X and Y, they're not called the midpoints. They're actually called the trisection points. So there's midpoint for you. There's the word bisect, and there's the word trisect. So that's the general concept. It's not that difficult. And by the way, if we have angles, it's the same thing. If I have an angle, actually move this down. So if I have an angle, like this, like that right there. What a lovely angle it is. You can name it whatever. We'll name it triangle pig, or triangle angle pig. Great. So if I take that angle pig, and let's say the angle is, I don't know, let's make it 60 degrees. Beautiful. If I want to take and bisect that particular angle, what I have to do then is just take another ray that goes, well, that's kind of right through the middle of it. If it takes the bigger angle and divides into 30 degrees here and 30 degrees there, beautiful, then that angle is said to be bisected. And this thing right here has a special name. No, it's not called the mid-angle. That's what most people think. It's actually called this. It's called the angle, and you should write this down too, bisector. So that is your angle bisector. It's the actual thing, guys, that's doing the bisecting. And yes, if I had another angle up here that would make it, or another angle, sorry, another ray, that would make this overall 30-degree angle there, I've actually just created the right angle. That's weird. So if I have three angles, that's 30, 30, and 30, then this angle, I don't know, I'll make it XIG, that angle. That angle is now trisected. Why? Because it's divided into three equal parts. And then this ray, let me change colors, this ray, IP, this is getting ugly now, but whatever. You're used to that, huh? That ray and this ray are angle trisectors. Anyways, so there's a couple little definitions for you. So let me cut back to the exact PowerPoint so you get a chance to write down word for word what the definition is. So here you go. If you have a point, or it could be a ray, or it could be a segment, or it could be a line that divides a segment into two congruent segments, then it bisects a segment. That's the exact wording, guys. Commit it to memory for the rest of the year because you're going to use that a ton. Now, you know what? Let me explain what this says. It says if a point, aka the midpoint, divides a segment, but it says you can have a ray, a segment, or a line. Let me cut to that so you can see what I'm talking about. I'll cut back up here. So what that's telling you is I can actually have a line or a segment that's doing this bisecting. For example, I could do this. I could have a line that goes up through there like that. Well, that line is taking this segment AB and dividing it, cutting it exactly in two pieces. Well, that line is bisecting the segment. So if this thing was, make these big old endpoints, if this was this is a segment, so this purple segment would be bisecting this turquoise segment because it divides it into two equal parts. That's pretty cool. No matter what, though, whether it's a ray, a line, a point, no matter what, that point that's doing the bisecting is still called the midpoint. Okay? So don't forget that. Back to the PowerPoint. Okay. So there's your wording of that, and here's a scoop. You can also flip this and say, wait a minute. So if I have a point that divides a segment into two congruent parts, it bisects it. Well, wait, what if I have a point that bisects a segment? Well, then it divides into two congruent parts. So all you did, guys, there is you just kind of flip-flop the two things. And in the next couple sections, we're going to talk about what that is when we flip-flop things. But those two are completely legitimate ways and things that you can write in two-column proofs. Commit them to memory. Here is the actual trisection ones. So I'm just going to have these pop up here, and you can pause the video and write them down. So those are just completely flip-flopped as well. So this says, hey, if I have 2 points that divide a segment into 3 congruent segments, it trisects it. This one says, wait, if I have 2 points that trisect a segment, well, then that means that the 3 segments are congruent. There you go. So, rolling into angles, it's the same exact wording, just with angles. So it says this, if I have a ray, but notice this doesn't say a point, a line, or a segment, it's a ray that divides an angle into 2 congruent angles. Then it bisects the angle. And this is the flip-flop. If a ray bisects the angle, ... then you should be able to finish it. But just in case you don't have it, or you don't understand, or you don't get the wording, here's what it should say. If a ray bisects an angle, that should say an angle, by the way, then it divides the angle into 2 congruent angles. There's your wording. And on to the wording of trisect with angles. So here's the wording. It says if 2 rays, if 2 rays divide an angle into 3 congruent angles. So if 2 rays divides an angle into 3 congruent angles, then they, meaning the two rays, trisect the angle. And the last one flip-flops, still the definition of trisect and angles, but it says if two rays trisect an angle, then they, meaning the rays, then they divide the angle into 3 congruent angles. Bam, there you go. Commit those all to memory. All of those with trisect and bisect of segments and angles. Actually, there's 2, 4, 6, 8. There's 8 of those right there. 2, 4, 6, 8. And not to mention, you need to look in your book and look at how it's worded for midpoint, because there actually would be 10 total, because you could say if a point divides a segment into 2 congruent segments, then it's the midpoint. And vice versa. If a point's a midpoint, then it divides a segment into 2 congruent segments. Hope you go back and listen to those two, because you need to write those down too. Bam, we'll see you in class. I'm excited to help you guys master these things. How to use them in 2-column proofs and other types of questions as well. Later!